Hopefully this is live. All right, Jerry, I am going to, we shall see if this is better, because I am now using 2 systems instead of 1 to make this work.
Well, I've got your live, it says live stream offline. Is that the one?
It should not say, it should say excellent connection. It's the new one for Patreon.
Oh.
Oh, you know what? I didn't update one. There is one thing I didn't update though.
Popped up.
It just popped up? Oh, good. My only problem is that... Hang on, I'm going to get off the phone here, Jerry. I am got to... Sorry, guys, your chat isn't the current chat. It's the old chat. So let me update that real fast. I think I found a way of working around my problems. And so, give me 1 second while I fix this. I am going to update the chat here. Right here. Hold on, you guys should see your pretty selves here momentarily. There we go. Now we got a working chat. Right? Yeah, don't panic. Now, so this is a slightly different method that I'm using now than I use typically. And so what this means is I'm using a different ISP for this. And yeah, things look a little different. So I have a much smaller chat. I've only got this many names. That's it. That's all I can see. Before I used to see all of your names. So chats will be a little bit tougher only because of that. But hopefully you guys hear me okay. And let me know. All good. No buffering. Everything cool. Did I solve the problem despite the fact that you know, this was kind of, remember, I'm a one-woman show here, so what I'll do is I'll get rid of that old stream. Good, all good. Thank goodness. At least I'm savvy enough to have another way around it. But I'm using now 2 computers to make this, to actually do the stream, because my first one, I have no idea, something broke. Meh, who knows? It was fine when I did class today earlier. All right. Hi, everyone. If you are dealing with Hurricane Milton, you know, hopefully this information will be useful to you. Those of you who are familiar with the Space Weather Prediction Center, they actually put up a big briefing today for a G4 plus level storm. You see I'm not in red, I'm in kind of an orangish pink, which is appropriate, I think. You will see things in this briefing that are different than what you saw at SWPC. And well, you'll see a lot more, but you'll see things that are different as well, because I feel that some of the stuff that they're telling, they do a good job in what they're doing, but they're not telling the whole story. So I do differ a little bit, and that's a scientific disagreement. I respect these guys immensely. I love what they do, and they're super important. But you will see a bit of a different approach with this today. For those who are in a hurry or have been, you know, very patient with this stream snafu, I will get to the BLUF, right, the bottom line up front. We will go through that quickly, and then I can do a deeper dive into other concepts and looking more detail at what's going on with the sun and with these events that are occurring. And then, of course, I'll take questions afterwards, okay? So let's just jump into it as quickly as possible. And yes, please be nice to both Jerry and Mike. They are the moderators, and they will want you to keep the comments relevant to the topic, especially in a briefing like this where it's super important people get the information. Maybe at the end we can deviate a little bit, but up front, let's keep it to this. So I'm going to start this briefing. Whoops, let me take you off the chat. And I can only see the chat now, sadly. I will only be able to see the chat when I pull it up on the screen, okay? So know that I cannot see the chat unless it's up on the screen, and I will do that periodically. So I will not be able to answer questions. This is cute. Now I can't get the mouse to work. Crazy. Hold on a second. All sorts of stuff is changing for me today. So, okay, chat is gone. All right? And so I cannot see what you're chatting. I apologize. I wish I could, but this was something I had to do quickly just to get this up here and make sure I can actually stream for you. So let me just go ahead and go through this. So we are taking a look at our sun right now. This is starting back on the 7th, okay? The reason why I'm starting back on the 7th is because there are a couple big eruptions on the 7th that are super important. Oh yeah, and Jerry and Mike, call me because I'm not going to be able to see you if things like battery goes out or anything else, so give me a call. Okay. So what I want you to pay attention to, of course, remember region 3842. This was the region that had been firing on the sun's far side before it even rotated into view. It actually fired an X9 class flare reasonably recently, and all of the big solar storms that we've been having over the past few days that got up to G3 level and actually came late, and all of this weird kind of fun stuff, and has been giving us aurora around the world. All of that came mainly from region 3842. Okay, now. You would think that this region, as it's rotating to the sun's far side, would give up the ghost, but it really didn't. It actually did fire a big solar flare along with a big coronal mass ejection. Right here, you'll see it here in just a second. There you go. This thing was pretty much on the west limb of the sun, but it did give us a nice partial halo. Okay. Not very big here, but watch as it expands. It's very, very dense, and watch as it expands. Do you see this right here? This is a shock wave, okay? So this shock wave plus the rest of this junk looks like this thing is almost 180 degrees. And when you get that, that means that we're probably going to get some level of disturbance, especially considering how dense the structure is. So this structure moving out is the first storm. Okay, this is the first storm. It's not going to be an Earth-directed storm. It's going to be a glancing blow, but I'm not sure we can completely ignore it when it comes to the bigger storm that comes later, and I'll show you why. Okay, after this, we then get a filament. You can actually even see it right here, right? This filament erupts. See it? Blowing off, and it's actually quite large. It goes all the way down here. Now, this thing most likely is not going to hit Earth. Okay, here is the coronagraphs, and again, you can see kind of a shock wave right here. You can even see part of the loop right here. Okay, so this structure is probably not going to hit Earth. It looks like it's going to go south of Earth, but remember, it is still tied into the sun, so it's got legs that could actually get in the way when it comes to some of the next stuff that we see. So that's now storm 2, but this is mainly storm 1 is the big one that we're thinking of on that side. Look how big this structure was too as it ripped off the sun. So that's a pretty big structure there. That one's likely going to go south, mainly southwest of Earth. Then notice this up here as we start paying attention to region 3848. I'll back it up just a smidge. This is late on the 8th, early in the 9th. If you take a look at this, you can actually see a little filament begin to rise. Okay, watch it and I'll pause it. See that? It paused right here. This is connected into this region. Watch what happens. I'll back it up a little bit. Watch what happens when this thing leaves. If you've ever heard of sympathetic eruptions, this is what happens. Okay, there it leaves and pow. Do you see that? So this lovely filament that just left ends up having a sympathetic eruption and ends up destabilizing this region, which was already unstable, and it launches an X. This is an X 1.8 flare, okay, and launches a coronal mass ejection. You can see these solar storms as it launches. You can actually see how big this dimming is right here. You can also see a lot of this ribbon out here. Okay. Now, why am I telling you all these details? It's because I want you to recognize that there are 2 storms in this one. It's not just one. It's 2. Okay. The first is this filament that's attached all the way in here, and the second is the obvious. Boom. Okay. Now, just so you know, this was a very, very energetic beast. And in the deep dive, I can talk about it in more detail. It actually had radio bursts up to 20 gigahertz, and that's very energetic. It did cause Starlink outages. It looks like it caused, there's a smoking gun that it caused Starlink outages. And it didn't have all that impressive. I mean, it's an X 1.8. You wouldn't think all that much about it. But when you take a look at the radio contacts, okay, this is G7IZU and G7RAU, HF and VHF radio contacts over the course of this day. This is where Dayside was. And if I back up just a little bit, you can see the radio was doing just fine. And then boom. Disappeared, and then it takes a little while for it to come back. Notice also we have a radiation storm building now. We are now at an S3 radiation storm. This will increase a little bit as time goes on because they're driven by the shock waves in front of these big storms, and so you will get more particles as probably tomorrow But we'll talk more about that in the 5-day. Now, on top of that, we have this. We don't have much in terms of chronograph. Hello? Oh, we don't have much in terms of chronograph observations. What are you doing? Hello, please? No, you're going, I need you to go backwards. I have gremlins in the system today. What is going on? Okay, 1, there, stop. No, too much. I have no earthly clue why I can't get this to go where I want it to. Are you going to stay? I guess I'll leave it there. It does not want me to show the very first image, so I'll just keep it here. Hope it does okay. Notice here, okay, so this is the difference image in chronographs. You can tell that it's a full halo. We only had a couple frames. But, and you can see even in the white light imagery, you see what people call a heart. Oh, how cute, right? No, these are 2 loops. The reason why there's 2 loops is because there's 2 storms. Okay, we had the filament eruption, and then we had this bad boy. Okay, so this is a twofer, right? So which means that there's a lot more mass in this than we might be led to believe when it's just a single eruption. Okay, so that's what gives me pause with this. Not to mention that we already have 2 other storms in front of this. Okay, and now I do know, and so look how much material. So if I go back, you really can see there's a lot more material, and because of how dark this is, right? Either how white or how black it is. And you can see even the material pretty well, even in just plain images, the intensity gram images of these in the chronograph. And what was I going to say? Oh, comparing to the solar storm that was launched during the X9 flare, which was also basically center disk, there was not much material in that eruption. That's why this is a much bigger deal. And people say, well, that was an X9 flare, so you should have a much bigger eruption. Solar flare intensity and solar storm intensity are not, you can't conflate the two. They're totally different, okay? So this is a much bigger eruption. This is going to cause a bigger storm at Earth. That's one of the reasons why we're saying a G4 plus. There's just so much more material. It's also likely why we have a radiation storm, is that when we actually go back and look at this, and I'll do it, I'll just set this back one time here. Watch this thing again from the beginning. Look at all this puffiness. See all the haze? Watch the haze disappear. Okay, do you see all this kind of hazy stuff? That's overlying material. Watch it all evacuate. See how it's all gone? It's all gone, all in here. So there was a lot of material in this particular event, a lot more than we had with the X9. This is why we're saying it's a G4. And I am not going to rule out a G5 simply because we have other storms in front of this. Okay? Now, we'll get back to it. This storm is, or this region is still firing. It fired an X-class flare that was occulted. We're going to be watching it on the sun's far side because looks like it's a pain. And then I know we had an M7 point there. There's the flare there as this thing goes to crucifix mode for one of its calibrations. Now, I'm going to switch to this. We did have, like I said, a 7.7 flare, I believe it was. I was told when we were having class. I did not have a chance to go look. Oh, yes, I do see it right here. Hold on. I've got it on another screen. It was about a 7.777. Okay. I don't know what region it was from. Someone will probably enlighten me when I get the chat back up. Now, let me get through this. So now we're taking a look at, cute. Let's do here. Okay. So now we're taking a look at our solar storm prediction model. This is going to be NOAA's version of the model. Top panel's density, bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. Notice this is starting back on the 6th. Why? Because this is the model for the storm that was launched to the southwest during, late on the 7th. Okay, so I'm going to start this and put this in motion. Hopefully it's going to start. There we go. And you're going to see that very slow, weak storm being launched to the south and to the west of Earth. Okay, take note of the arrival time, 0600 on the 11th. Okay, take note at how much in the Earth-Sun line this storm is. Quite a bit. Okay, if you have another storm that's coming out after this, This one's going to slow it down. Now, you're going to compress the two, okay? But this one's going to slow that one down. Now, let's fast forward. And so they have this as a, a medium event, pretty mild, 15, for density for a model like this. It's obviously it's not super realistic, but it's not going to be moving all that fast. I've got it really moving at about 400 kilometers a second. So pretty mild storm on its own. But we had that big X 1.8 flare with the big twofer solar storm, right? The filament and this big flare-driven, what we call a flare-driven CME. And that's what we're going to see next. If I flip to it, are you going to work for me? There we go. No, you're not supposed to go that far. Boy, this thing is just, it's not behaving well. Okay, please play now. All right, so same thing, but now we're talking about the X9 or the X 1.8 class flare and the solar storm that's associated with it, the one that launched today, that the Space Weather Prediction Center had their meeting about, their briefing about, and they said it's the only storm. Well, it's not true. That's not the only storm, right? We already just saw one from a model that they put up 2 days ago, or yesterday, actually. So here is the fast storm coming out, and this puppy is fast, okay? And they've got this structure hitting by 1500 UTC on the 10th today, right? It's 156 UTC right now. So in about 9 hours, they expect this storm to hit. The only problem is this storm has a clear shot in this model. They don't recognize or let you know that, hey, there was a slower storm ahead of this. Okay, and yeah, it was kind of off to the side, but how does that impact things? Well, obviously I can't go back and run NLUL. All right, wouldn't do it even if I wanted to. But what I can do is, with a little bit of magic, I can align the two plots, line the two runs, synchronize them, and see what we get. So this is what we get. So you're going to watch. There's the first slow storm being launched. Do you see it? And I have it kind of a ghosty kind of look. Now, just behind it, you will watch that second storm being launched. See it? So this is now, in time, the second storm being launched after the first, which SWPC did not do on their formal model that's out right now. Perhaps they'll do it later. I don't know. At any rate, watch this thing as they don't interact in this version, because I'm just overlaying them. The second storm clearly overtakes the first and hits Earth. The second storm, or the first storm, is back here now. Do you guys see that? I'm going to back it up so you can see that one more time. Okay, first storm is being launched. Second storm chases and rips right through the first. Okay, this is not physical. This is not what's going to happen. The first storm is going to hit the back of the second storm, or the second storm is going to hit the back of the first one and push it and compress it, and they're going to spoon, as people call it. They don't cannibalize each other. They don't mesh into one, but they pancake next to each other. So that faster storm is going to push the slower storm from behind, but that slower storm can only speed up so much. So the idea that this is going to hit, the fast storm is going to hit by 1500 hours today, 9 hours from now, I don't think is true. If we get hit by something in 9 hours or around there, likely it's going to be this slower storm being pushed by the fast one. Okay? So what that means is that when we start seeing storming, and I would put a big error bar saying we could start storming as early as, 10 hours from now, or we could start storming 24 hours after that. Okay, to me, this is a huge margin of error when it comes to the modeling of this. And part of that's because these are fast, and part of this is because there's a lot of junk in the way. Okay, and that this was a two-parter eruption. So this isn't a single CME. This isn't a single storm. This is a two-parter. So the structure of this thing is going to look a bit weird, and it's going to affect its propagation. So as this comes out, expect that we could get some level of storming, and then we could very well see a bigger hit later. Okay. All right. Hopefully that makes sense. And I don't have any comments up here yet, but I will. Let me do the 5-day. Oh, wait, I have one other thing I want to tell you. Okay, so that's going. Let's switch to our moon. I just want to let you know we are passing through the second quarter phase on our way to a full moon. If I said that right, first quarter phase on our way to a full moon, and by the 13th we will be about 78% illuminated. So it's going to be a little bit touchy to see the aurora. Okay, but we have some fun because Comet A3, what I call T Atlas, because I can't pronounce this name. This is going to be in our dusk sky, and what's cool is that as it's crossing through the sun, as you see like that, it's going to have a comet tail flip because of our orientation as we are moving in our orbit. We are passing this comet in our orbit, and so it's going to go from one side of the sky to the next, and the comet tail is also going to flip because of the direction it is facing with the sun. So as it begins to look like this, what ends up happening for us is that we'll see it in the dusk sky, and it'll have a comet tail that looks a lot like this around tomorrow. And then by the 13th, you get a comet tail out like this, and then you'll have even the anti-tail, which is that ion tail coming out that way. So be prepared for it for those who want to. I think it's coming. There we go. Want to kind of chase it. It's going to be above the constellation Libra, and you might actually get some really good aurora shots with it if you can. Although aurora is rising in the east, and this is, going to be in the dusk sky, it might be a bit harder, but who knows with the amount of aurora that we're going to be seeing. Okay, so, and with that, on to our solar storm conditions and aurora possibilities over the coming week. I have not seen what the Space Weather Prediction Center has put out, so I'm just guessing, educated guess of what they've actually going to be putting out, something along this line. But understand that I have this perspective of the previous storm slowing things down. So at high latitudes, I am definitely expecting severe storm, easily see a G4. Okay, and I'm saying a G4 plus. I'm not going to push it as far as a G5, but I'm not going to rule it out, especially at high latitudes. I'm going to say we have a 90% chance of a severe storm. That's at a G3 or higher range, right, which is essentially 100%. Now, granted, in order to get a G5 out of this, the stars have to align, right? You have to have the right magnetic field orientation, so the structure has to be aligned the proper way. The storms have to line up. In other words, the slow storm has to be pushed really hard where it's going to compress right into the Earth, so we have this huge peak in density and stuff like that to get a scenario that's similar to what we had on May 10th. I'm saying maybe 1/10, 1 out of 10 chances would get us to a G5. So it's a slim chance. Okay, likely we're going to be sitting at a G4, even at high latitudes. It's just going to be a strong G4. Okay, but expect to be on storm watch today, because I'm giving us about a 50% chance of getting hit by something where we go up to a G3 level or beyond by the 10th. But likely the strongest storming will be happening on the 11th. Okay, and then expecting it to calm down a bit on through the 12th, and then after that we're going to get some fast wind. Okay, so we have a fast wind stream that's coming behind this, and so that will delay the slowing down of storming. So we could be conceivably at high latitude storming all week, which I'm sure aurora photographers who are completely exhausted with all the chasing they've done recently don't mind that at all. Now, let's see if I can get to mid-latitude stuff here. There we go. At mid-latitudes, well, again, we could start storming here today, later on today, but I'm only giving us about a 40% chance of getting in a severe storm, which would be an S or a G3 or higher. Did I say S3? I probably said G3. I hope I said G3. A G3 or higher. And then by the 11th on Friday, again, likely seeing a G4 if the orientation of the magnetic field of the storm is proper, or the orientation of the previous storm is proper, right? But we are dealing with a slow storm ahead of us, and we're dealing with the fast storm being a two-parter. So we definitely have the chance of getting to G4, and even I'll eke out a chance of a G5. Okay? So it's just pay attention. But this is likely going to be over the 11th, okay, which is good. I want it to, the slower it comes, the better off we are in terms of it not being quite so strong, and it gives people from Milton a little bit more time to get through the storm and probably try to assess some damage. Right. By the 12th, I'm expecting something like minor storm conditions at mid latitudes, and then again we get a little bit of fast wind, but it's going to calm down a bit faster at mid latitudes for you. So that's my outlook. Again, if it differs from SWPC's, I apologize. I just didn't have a chance to check their numbers to kind of help see if I wanted to align myself with them. But this is all through my my take on where the storming, what's likely going to happen. Okay, solar flare and Dayside radio blackout outlook over the coming week. We are sitting around 225 for solar flux, and that's going to dip down possibly a little bit as region 3842 completes its rotation behind the, to the west limb and behind the sun, or to the far side rather. But then we'll probably pick up again. We do have a couple big flare players on the far side that are going to be rotating into Earth view here in the next maybe 2-3 days. There's 2 of them that I'm paying attention to. I didn't highlight them here because it's not quite as critical, but that's why I believe we might have some activity or some solar flux pickup. Not really expecting big solar flares. I think the biggest flare players on the disk are Earth facing right now. NOAA's giving us about 75% chance of M-class flares at an R1 to R2 level radio blackout and about a 40% chance of R3 level radio blackouts. Because of these regions, region 3848, 3842 is disappearing, but we do have a couple others that are big flare players, so we're paying attention to them. I think that might actually drop a little bit as we get to the end of the week. Region 3848 will be starting to rotate to the sun's far side, and hopefully that will give us a bit of a break as long as no one else decides to really act up. So I'm having us drop from severe noise down to moderate noise as we move into the early part of next week. And now, as we switch to our radiation storm of polar aviation outlook over the coming week, we are sitting at the D2 minor range right now because we are dealing with an S3 radiation storm. Likely that's going to climb a little bit to a D3 moderate level, which we haven't seen really, I think, in this solar cycle, because we've just grazed the hairy edge of an S3 radiation storm, where at this point on the 11th, and I'm assuming that this is when the shock wave from the big storm will hit, and that's why we'll peak and get a little bit more intense radiation during the radiation storm. We'll get a bit of a peak for a few hours, still at the S3 level, but then beginning to calm down after that. As soon as the big storms begin to pass, then things begin to calm down with radiation storms. So for you aviators at flight level 360, you're gonna have a little bit of a tough time here over the next couple days. It's probably gonna make your VHF comms noisy. Please, take that into consideration. Once we get back to the D2 minor range, things will be a lot better. And also, of course, you high-risk passengers, and this is aircrew and prenatal passengers. Definitely take this into consideration. We're going to have at least 100% chance for the next 2 days of being above an S1 to S2 level, okay? And then things will kind of calm down after that. So watch those ICAO advisories often. If you are high-risk passenger, please consider this, and especially if you're doing chemotherapy or radiation or anything like that, or have implants, medical devices that are susceptible to things like single event effects. Please take this into consideration in your plans and just have your mitigations ready. And that, folks, is it for the big thing, the BLUF. So let me put your chat back on so that I can actually see you. And I'm going to move this to something a bit easier to look. My goodness, that looks terrible. Let's put the sun back up. It's easier to see. Okay, guys, so I can finally see your chats now, and hopefully this briefing was a good one. I'll stand over here so I don't plug your chat, and let's see. The only person I listen to. Okay, thank you. That's how Kurt Miller found you. Yeah, sorry about the stop and start today. I don't know what's going on with my system. SWPC issued a watch for the 10th and the 11th. You're quite close with it. I'm not sure if SWPC has considered the other CME. I couldn't tell what that said. Again, I can't control this, sadly. Great information, good. So what's forecasted for the 10th should be happening for the CD. What's forecasted for the 10th should be happening on the 10th. They're all UTC times. Okay, so look at everything from UTC, and again, everything, put a window on it, right? Give yourself 24 hours plus or minus. If you're an Aurora photographer, definitely do that. If you're an emergency communicator, my suggestion to you is try to use the Dayside over the next few days. Try to use the Dayside as much as possible. You will get noise, you will get radio blackouts, but that's likely going to be better than the night side. Okay, if you're a drone flyer and you're doing if you're doing GPS runs, if you're doing search and rescue with GPS, please be very, very vigilant. I know you have certificate of authorization, paperwork and stuff, and you've got that certificate of authority to fly, but GPS could be very wonky. Your reception could be very weird, and your drone could be very strange and fly in very unpredictable ways on the day side or the night side. So just be aware of that, especially when you're flying in and around people. Why don't the storms merge? They pancake because they have magnetic fields that prevent them, just like fridge magnets. If you ever put fridge magnets together, there's two ways they go. Either the fridge magnets have polarities that are of opposite each other and they click together and they like to stick, or you have the same polarity of fridge magnet and you push them together and they don't like to, they push themselves apart. And that's kind of what we have in the solar wind when these structures come next to each other. They typically don't stick. They typically will push each other apart. But even if they do stick, they don't stick very well, and they don't merge and just smush into each other because the magnetic fields kind of, they're forces. They actually create, they're the whole reason why these structures, what we call them, are solar slinkies. It's the whole reason why we call them that. They look like flux ropes, kind of like a slinky. And so they don't, when they, they're reasonably tough. They don't, they bend and whatnot and distort, but they don't just shred typically, unless the magnetic field is really weak. Okay. Always great info, always learn a lot. Thank you, bunches. You're very welcome. I appreciate that, Otter Silver. Thanks a lot from Chile. You're very welcome, Javi. Please speak to help the North Carolina recovery operations. Yeah. How I help is I help the amateur radio operators with their nets and let them know how the space weather is affecting what they're doing. I also talk with meteorologists who are reporting on these events, and I try to help educate them as much as possible and give them real world expectations. And yes, again, sometimes the information I have is going to be very different than some of the official channels. So these are ways that I can help, but I don't lobby, if that's what you mean. That's a problematic thing. I try to stay as diplomatic as possible, and because I need to work with these folks, right? So, was it from? Okay, thank you, Steffi. The M7.77 was from 3844. Yeah. How far from the poles will the Aurora be visible? Now that's going to depend upon the magnetic field direction of these structures, but considering we have one that's in front at least, and then we have a twofer, right? There's at least 3 storms there that give us an opportunity to get the right orientation. So at some point in this mess of stuff, we will likely see some southward field, and it will likely be in the middle of something that is quite dense and quite strong. So if we get some decent southward field, which I think there's a high probability of that, I believe we will, you will easily see Aurora deep into mid-latitudes. Now, will we see it as far south, down to the Yucatan? No, like I said, that's a 1 in 10 chance that we'll see something that intense. That would be G5 level, right? It'd be baby G5 level, but I'm not sure that this one has the gusto to make it to that, but I guarantee you on social media, we will be, all of us, there's a whole, army of people now on social media who are getting skilled at space weather prediction and nowcasting. And so all you have to do is come anywhere on social media and you'll get alerted to whether or not the storms as they unfold are going to have the appropriate magnetic field direction. So worst case scenario, I think you're still going to see Aurora, especially early on. If this storm is extremely fast and hits quickly, what we're going to be worried about is the EMP, the E3 component of the EMP. And I'm just hoping that's not the case, right? This was a pretty fast moving storm and originally had a forecasted travel time of something barely over, like 30 hours. And that's pretty fast for these storms. So could that cause an EMP? yeah, I think our grids can handle it. Just like I had said in the previous storm forecast, if you feel compelled and you want to help, feel free to dial down your electricity. Does it help with EMPs? Not necessarily too much, but anything can help. I've talked to some folks, some risk management folks at the DOE, and they have discussed talking to the public about putting out warnings and asking people to dial down their electricity usage during the storms. So I said, well, would you mind if I do that? And he says, no, I think that actually might do some good. So feel free to help out that way. Take a little bit of a load off of the grid over the next couple days, and we'll get through this pretty well. It should be easier than the May 10th event, and we did pretty well back then. So I have a pretty high confidence. The issue, of course, is in those storm-ravaged areas with Milton and all that kind of stuff. Okay. I'm looking for questions. How do we know what the incoming field is? We don't know. That's just it. We know the magnetic field. Obviously, these storms have magnetic field in them, but we don't a priori know what direction the magnetic field is going to be. These, especially something as complicated as this, as these storms interact, they can distort one another. You already saw that one storm that's coming off from 38, region 3848. That storm is incredibly complicated. It's got the let me pull this up, right? It's got the, hopefully it'll come in a second. Catch up with me. Here it comes. It's got this heart, right? This heart shape right here, right? So that you've got one loop from the filament, and then one loop that's the storm, from the coronal mass ejection from the actual flare area. So it's a convoluted structure, and so knowing what the field is going to be a priori is pretty tough. Okay. How long can the proton storm last, and can that affect geomagnetic storm if elevated? No, actually, the solar storm that creates the geomagnetic storm, right? It's the Earth's reaction to the solar storm that creates the geomagnetic storm. That solar storm is driving that radiation storm. So that's why as soon as that big shock wave, it's actually the shock wave in front of the storm. And as that shock wave passes Earth, that's when things will calm down. So you'll see it rapidly fall at that point. But prior to it, as a matter of fact, I'll do this. I'll switch to, here we go. And I know it's a little bit of a mess with your chat over it, but you can see this right here. I'll pull this up. So, yeah, I don't know if I want to toggle full screen because then it makes it harder. Okay. But you can kind of see this. Notice that it was kind of beginning to graze upward, right? Up to the this is the S3 level for a radiation storm. All right. And notice that it's continuing to climb. And it's just kind of kind of just sitting here, grazing the S3 level, but you'll see pretty soon it begins to peak. And as this begins to peak, not these are the higher energies, but as it begins to peak, then you'll know that storm is getting really close. This is what we also call a hard spectrum, because the 100 MeV particles, the really energetic ones, which is the green trace, they are elevated above this level here. This is also an S1 radiation storm, but for 100 MeV particles. So we are still at an S1 radiation storm for the particles here, and those are the particles that we don't like it when astronauts and people in planes get hit with those. We would prefer not to ever have these hard spectrums. We'd rather have just this one, just this line. These ones need to go back down. So this is not a fun. If you have to fly over the next couple days, I apologize. I wish it weren't quite that bad. So that's the end of that's the indication of that. All right, what else can we talk about? The double is it a filament and an X flare? Yes, it was a filament that then kind of destabilized a region that was already planning to flare, and then it flared and gave us a big coronal mass ejection as well. So it's a twofer, as I call it. Question: have you ever worked with power utilities on what criteria they would use in severe situation before they would begin shutdown and isolation of vulnerable grid components? That is a very proprietary question. Sadly, I have I have worked with people who do that. So in other words, I don't directly interface with the power grid companies, but I sure hear lots about stuff from people who do, and also people who, scientists, both on the scientific side. So for instance, Antti Polkinen is a good friend of mine, and he really helps set the standards for the NERC and the FERC and how to mitigate. He and of course a team of people, but he was a heliophysicist who's really pioneered and really has been, that has been kind of his baby, and taking care of these power grids and getting them to understand what geomagnetically induced currents can do. And so he was very excited back in May when we were able to, or when the procedures, the mitigating procedures that were put in place, they were put in practice. And the grids, although they had some issues, they were minor. They were things that people could handle just within the procedures themselves. There's also some hardware that's being put in place. People are working on capacitors and having the grid actually decouple from the ground so no more green energy can get into the lines. During big geomagnetic storms, the problem is, of course, when you do that, you're decoupling, you're taking the ground wires off. So you're having the grid free float for a while, which is dangerous in of itself, but it ends up being less of a risk than actually continuing to allow the green energy to feed into the lines, because that can really hurt the transformers. And then, so I've worked with people on the scientific side, and then I've also worked with people who are actually in industry and are trying to deal with things like wet and dry transformers, and then trying to get the power companies to make the changes that need to be made and make the accommodations that need to be made for, let's say, a wet transformer versus a dry transformer. And I talk a little bit about that stuff in my courses, in my mini courses. I think it was the E-series where I talk about power grids, and I give you more insight as to some of the current struggles we have with them. Of course, now green energy, the renewables, that side of power distribution, not distribution, but power generation, is adding a whole new level of complexity, because these new methodologies have, and hardware have a lot more capacitors, a lot more components that are even more susceptible than the old, than the standard generation mechanisms and hardware. So that's a whole new generation of issues when it comes to space weather, but they're going to have to learn how to deal with that. Do I have anything at home to protect me from an EMP? I have my UPCs, my battery components, stuff like that, but no, I don't have a big Faraday cage or anything like that. You're really not going to get, the EMP that you're going to get is not something like what you would expect with a weapons grade EMP, okay? There are 3 different types of EMP, EMP 1, 2, and 3. EMP 1, if I get this right, EMP 1 is going to be the man-made, like nuclear detonations, okay? You get a big EMP with that because they're very intense, very powerful, very quick, right? The second, I think EMP 2 is lightning. That also creates a pulse. Obviously not quite as quick, not quite as widespread. And then you have the E3 component, and E3 component is actually quite slow. I mean, it occurs instead of, microseconds or, even nanoseconds. You're dealing with something that is occurring over seconds, and even longer than that, 30 seconds. And if you're, and the reason for this is because when you're compressing the Earth's magnetic system, right, you're compressing an Earth's magnetic field, you have a big storm that comes in and does a bumper car effect. It hits the Earth like a brick wall. And that compression can really cause Earth's field to shrink really fast, but that causes the field strength to go up. And so you're increasing the field strength really, really fast, okay, relatively speaking. And you're doing it globally, right? So that's what makes an E3 component very different than the other two. It's slower, but it's global. And so big systems like power grids, right? Those, big unbroken lines that span for hundreds and hundreds of miles. Those are the systems that can be compromised by it. Little tiny systems in our house cannot be compromised. I mean, they may be, you may have issues from the dirty power that you get from your power grid, right, under these circumstances. But it's not going to be that something out in the air, the EMP is going to take your system out. System's too small. Okay, same thing with those devices, insulin pumps, pain pumps, neurostems, that kind of stuff. Don't worry about those with EMP. Too small, right? Car batteries, don't worry about it. Those are not the vehicles that get affected by geomagnetically induced EMP. Okay. My impression is that you are the astronomical version, much like Dr. Lucy Jones of Caltech. I thank you. That's very kind of you to say that. I respect Lucy. She's wonderful, and she responds very well to the community, answering questions when there are big earthquakes. Yes, yes, yes. So, do you think Aurora in Oregon with light pollution? Yeah, absolutely. It's going to be the biggest thing you'll have to fight with the light pollution and the addition of the moon, right? That's going to be your biggest issue. So, the retraction of the G3 that pushes the field down to the surface is just as dangerous as the compression. The retraction, what are you talking about? You're talking about are you talking about the actual solar storms themselves, or are you talking about we're talking about that E3 component of the EMP, and you're talking about the compression and then as it lightens up and lets go? Yeah, okay. The compression's going to be worse though, because the lightening up of it it's not. A big solar storm has a lot of speed, and in this case, there's going to be a lot of mass. So you're going to have a lot of dynamic, you're going to have a lot of dynamic pressure. God, I could not think of that phrase. You're going to have a lot of dynamic pressure pushing against the Earth's magnetic system. So it's going to sit here as you keep blowing on it with this harsh wind. It's going to sit here and go, blah, 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 the front of this structure, right? If I had a model, I'd show you. But like if you think of the Earth's magnetic system as kind of at least the heart of it as a coil. Where's my Earth? I don't know where my Earth is. Let me see if I can find it real fast. Yeah, there it is. So if I take Earth, here's Earth, and I put it in this coiled slinky, nest it in the middle, okay? So that's kind of the heart of the Earth's magnetic system. Now, if you take the solar wind and you blow on it from the side, you're going to compress this front end, and you're going to draw out this back end. So this back end will become a comet tail, right? That's the magneto tail. The front end gets squished a bit more because it's springy, right? So I can't squish a slinky, sadly, but if this were a plastic slinky, I could probably squish these in a little. And so that's what's happening, is that you're going to get a first initial wallop. But then after that, as the big solar storm continues to blow over this structure, over the Earth, it's still going to be pushed here. So it will go in intensely, and then it will come out a little bit and back in a little bit, depending upon what the dynamic pressure is of the system, until that entire storm system has blown through. So it really won't be nearly as big of a recoil, so to speak, and it won't. That's not really the source of these big EMPs. The EMP sources are more the initial hit. Okay. Okay. Let's see. What else? Thank you for all of your great work trying to get the word out via X. Excellent. Please do. Yes, yes. Let them know. Let them know that. And if it doesn't arrive early, like when Swipsy says it will, don't lose hope. Just give it time, right? This is going to be a really tricky storm, set of storms to try to figure out, because it's just because of the way it's, just because of the fact that they've got these at least two storms in front and this bizarre twofer orientation, heart-shaped, filament, and it's like a couple in love, right? That's why it was heart-shaped, because it's two of them. Oh, look how cute. Look at the storm couple kind of thing. So it just makes it more complicated because of that. All right. Any other questions, guys? I see someone said they don't understand any of it, but they're trying to learn. Good, good. This is kind of like drinking from a fire hose, because this briefing was not necessarily meant for the faint of heart. I will also go ahead and take a look at Milton tracking right now. They're tracking Milton live. This was 4 hours ago, so it was just making landfall, and I know that people are, let me pull this over. I know that people are definitely dealing with this pretty intensely right now, and if we look at, actually I can look at, let me do this, pull this down. Here's right from the NWS website. Let me move this way, if I can. Make it bigger so you can see it. Yeah, look at that. So this is what's been making landfall over the past, I think this is maybe now an hour old. But as you can see, it's just hitting. So as this makes its way across Florida, I am hoping that the solar storm will be, even the beginning of the solar storm will be late. So it gives this thing a chance to go all the way across Florida, and people get a chance to kind of wake up in the morning and assess some damage before, and be able to use amateur radio right as much as they need to before things get really ugly. So again, amateur radio operators, if you're listening, if you're planning on doing the nets, or if you are someone who are planning to inform the nets, please let them know. If they have trouble on Earth's Dayside because of radio blackouts, switch to higher frequencies. Higher frequencies will survive, will stay more audible, more understandable through solar flares, okay, through radio bursts. We have been having really tall radio bursts, really high frequency radio bursts, so that may not always be the case if we get another big X flare, especially from region 3848, but it's worth a shot because guaranteed low frequencies are going to be a problem. And then, of course, when you go to Earth's night side, when we get the solar storm hitting, then switch to lower frequencies than what you would normally use on Earth's night side, because with solar storms, the lower frequencies actually do better. So it's the opposite of the day side, okay? And again, if you're a drone pilot, be very vigilant near dawn and near dusk. Be very vigilant if you're doing any search and rescue at night, which you probably won't. But if you do, be very vigilant if you see Aurora anywhere nearby. Even if the skies light up red. In your case, you might see red skies. You might have trouble with satellite lock, okay? And then your drone may fishbowl. If it fishbowls, you know you're in trouble. Okay, that's a classic example where it's losing lock and it's picking different satellites, different groups of satellites, and it's trying to get a decent position solution, and then it loses those satellites and it acquires other ones in a different location in the sky, and it changes its orientation, changes its position according to what it thinks is supposed to be the right place. And so it will kind of do this very strange dance in the sky. That's when you know you're in trouble. Okay, and if that's happening around people, that's a bad thing. All right. Other questions. Do you think the energy from flares, protons, or solar storms can affect hurricanes? You know, we've actually seen some of that. Yeah. Papers are beginning to come out in mainstream science, so it's kind of nice. University of Reading is one of the leaders in this. We see coupling from the sporadic, from the E layer, basically. What seems to happen is that when we get radiation storms and even solar storms, geomagnetic storm effects with Aurora and everything else, that can cause a lot of extra particle, extra electron content, especially in the E layer. And we've seen through gravity waves that come up from the center of these structures, they propagate upward, and they actually will disturb the intervening space between the tops of these structures and the E layer, and the E layer then will dump all of its charge and disappear. The E layer itself will disappear in that region, dump all of its charge into these structures, and that intensifies the electric and magnetic fields, which has been argued to potentially intensify not just the amount of lightning, but also the winds inside. So I know several people, Amy Metz, for example, who's a SWEN graduate, she actually uses that techniques like that in her forecasts all the time. She calls herself not the space weather woman, but the weather woman. And she has a Facebook page called the Wonderful World of Weather, I believe. And so she's been doing this kind of forecasting for quite some time. And there also are papers about that discuss how Aurora, for example, does heat the upper atmosphere, and Finland uses less energy or their heaters during times where there's a lot of aurora. So we know that we do get heat, the heat from the auroral process itself does get radiated. I think radiatively transferred because it's collisionless. So I'm not really sure how else it gets transferred. But the heat does get transferred and convected down, and down into the neutral atmosphere. So if that is lighting up, if we're getting aurora all around the world, basically from a G5, I don't see any reason why that heat can't also transfer. How it ends up affecting the neutral atmosphere, I don't know, right? You need a meteorologist for that. Hopefully we're training enough of them that they're going to start really doing a lot more studies on coupling between the charged layers and the neutral atmosphere. But yes, it's work that is in progress. And I know a lot of fringe scientists have been talking about that for a long time. And finally, mainstream science, we're getting a little bit of trickle funding into this arena. And that's going to make a huge difference probably in the next decade. You're going to see a lot more coupling between terrestrial weather and space weather, both from terrestrial up and also space weather down. And you're going to see a lot more meteorologists with space weather expertise, if I have anything to say about it. Right? I'm continuing to train, so we'll see. Hopefully we can get this new field started up. Okay. Do I think this storm could be the best thing since May? Odd brother, let's see. Again, I have to, in order to say that, I have to assume certain things about the magnetic field. I do think we have a good chance of getting aurora, getting decent aurora. I don't know if it's going to have as long an impact as the May storm did, and I don't know if the impact is going to be quite as intense. But I do think it'll be a good show. Do I think it's going to be even, I mean, you could even question whether or not it's going to even be better than this just the last few days, because we had really sustained southward magnetic field. So we had lots of aurora for a long time. Some people may walk away thinking that the G3 storm we just had might be better than this one. But it all depends upon who you are, right? Aurora photographers may like the G3 better than this G4, or even if it becomes a G5. They may prefer that one over this one, whereas we may have issues with GPS and farming again, right? Precision agriculture. We're just going to have to see. I'm not even sure if precision agriculturists if this is a weekend for them, that is going to be, or a week for them where they're busy planting or dressing or spraying or whatever else. So we'll just have to see. But it does have the potential. It's just small potential. This is only the second time in 20 years they've put out a warning like this. Yeah, well, that's because our sun's been asleep. And this is one of the other things. I guess I could stop showing Milton. This is one of the other things that I wish that Swipsy had been a little bit, stated things differently. The solar cycle that we're in right now is a typical solar cycle. Okay. The reason why we haven't seen anything like this in the last 20 years or almost even 30 years is because the last couple cycles we've been in have been very sleepy. Our sun, they have been the atypical cycles. Cycle 23 and cycle 24 were atypical. This cycle is a little bit bigger than average, or about average, I think. It's about average. We used to get multiple G5 level storms over the course of solar maximum, or over the course of a single solar cycle. I can go back historically and show you. There have been times where we've had G5s about once every month or two for almost an entire year. Okay, and so this is not outside of the realm of of even normal. What was outside of the realm of normal was having an entire solar cycle go by and we didn't even get one G5. That was last solar cycle was unusually quiet. Okay, so please don't think that something's going wrong with our sun. Our sun is not doing anything abnormal. It's just remembering what it used to be. Okay, and I would not be surprised if solar cycle 26 is even bigger than this one. Wouldn't surprise me. So this is why it's super critical for us to get everybody to understand that space weather matters. Especially as we get more technologically savvy. We had 30 years to develop a lot of space-age technology without our sun getting in the way. Well, now the sun's getting in the way. Okay, it's waking up and it says, okay, you guys had your fun time, now it's my turn to shine. So don't freak out. It's not, this isn't, there's nothing abnormal about this. We just need to understand that we do live under a star that can be angry, especially anywhere near solar max and the declining phase. No, Jack Ashmore, you're asking whether or not the magnetic field of Earth diminishing, the dipole field component of the Earth's magnetic field diminishing, why that's making things more crazy. No. Like I said, our sun has been easily this crazy historically. Look back in the 1950s. And our Earth's magnetic field was much stronger then, and yet we still had the same kind of G5s. If anything, we had even bigger, we had a lot more really big storms back then. And so that's why I look at this, and I know that it's not a function of the magnetic field of Earth, okay? It's because we've seen it historically, and Earth's field was fine back then. B, have you looked at your cell phone lately, right? These cameras are far, far better than the most expensive cameras back in the 1970s, let's say, when we even had the biggest solar cycles that we've recorded. And on top of that, we have social media. We get news out a lot faster. So there's so much more recording, so many more people aware, and so many more ways of recording the evidence of space weather impacts. So not only has our technology changed, right, but our way of communicating it has changed. And so that's why people seem to be so much more aware. But our sun has done far more than we're seeing now. And our Earth's magnetic field, if anything, the power grids, as I've said before, the power consortiums and power grids, they're actually very happy that our Earth's field is diminishing, at least the dipole field component is. Even if our dipole field component flips, which we're not sure it's going to, it may just come back. It's done that many times in history. So we can only call it an excursion. We can't even call it a flip because we don't know that yet. But even if it does decide to flip, and so for a few, a finite amount of time, the field will be zero, that dipole field component. We have field components underneath it, right? We have the quadrupole field component, the octupole field component. Those components will take over, and people have already done studies showing that these field components can easily stand off the solar wind, even with really strong events like Carrington. It does not take out our atmosphere. We're fine. And the grids, the power grids, they're like, yay, we love this, because if you have a weaker field, magnetic field on the Earth, what we call the Earth's magnetosphere, if that field is weaker, then the GICs that are induced in the ground and ultimately into the power lines are also weaker. So that may be another reason why, for example, we did well with this G5. It was a baby G5 that we had back in May, but maybe part of the reason why we did pretty well with it was because Earth's magnetic field is a little bit weaker, so the GICs are meh, not so big. So everything with space weather is a mixed bag. Okay, not everything is all catastrophe and disaster. Please don't think that. Okay, and as you can see, I'm not worried about this storm. Okay, question. Big fan of the things you post on X. Oh, good. Any thoughts on the Northern Lights? Oh, poop. I missed it. Any thoughts on the Northern Lights something? It went too fast. Sorry about that. I've never considered the multi-field underneath. Yes, look at spherical components or spherical harmonics of really of anything. You'll see, and if you look at it from the perspective of magnetic fields, you'll see dipole, quadrupole, octupole, and then it becomes it's a multipolar field. It's a series, kind of like when you do Fourier analysis, right? You try to make this one wave, and how you do it is you put together a whole bunch of different waves of different wavelengths and frequencies, and you keep adding them until you end up making the wave that you started with. So you can break it down into components, and this is what we do with our Earth's magnetic field. It has a particular shape, and so we keep building up components at higher order and stack them on top of each other and add them together until we get the shape that we expect, that we see in real life. And so we see these other components, and when some of these components flip, well, that's just what they do. Doesn't mean that the magnetic field completely goes away, right? Just that component does. Okay. What else? Yeah, this is the opening scene to The Day After Tomorrow. No. Oh, and this, yes, is the comet. I was so hoping that we'd get a chance to see a comet tail disruption. because as this big CME goes by, oftentimes the tail gets broken off like a gecko, and it goes, and it just kind of disappears, and the comet keeps going, and then slowly it grows a new tail. It's pretty fun. But I don't think we're in the right orientation, because the comet's heading really toward the sun, and we're kind of in line with it. So we're looking kind of up the tail. That's why the tail's so bright. It's because we just are looking so right down the line of it. We're not seeing it from the side. So because of that, if a disruption occurs, we may not see it, because we're still kind of like, it's like if you're Earth and I'm the sun, or I'm the comet, and here's my tail coming straight at you, right? If it breaks, how can you tell? Right? See, I broke it. How do you tell if you're looking at it like that, right? That's kind of how we're, you have to look at it. You have to look at it from the side, right? Now you can see it if it breaks from the side. But if I'm really right along line, I break, you may or may not tell. That's what we're dealing with here. So we may not get to see a tail disruption, but you will get to see this whole thing swing from one side to the other, which will be nice. It'll go, I think it'll do that in Soho. I may be wrong, but you'll see that in the night sky at least. Okay. You guys are socked in with fog. Well, again, I don't know if the storm is going to hit right away. Tabitha, the question was about the timing of the Northern Lights in Maryland. Timing, guys, I'm not going to be able to tell you timing. What I will be able to tell you, because I told you, give yourself a 24-hour leeway one way or the other, both with 24 hours ahead, 24 hours behind, because there's more than one storm, number one, and number two, the models are showing the storm without anything in front or behind it, and that doesn't help. It leads to big ambiguities. Okay, what else? Let's see. I was going to say one other thing, and I completely forgot what it was. What I will tell you is regarding Aurora. Just know that as night falls, if you're in the north, look to the northeast. Okay, because Aurora rises in the east, and then as it goes over the course of the evening, it will set in the west. And if you're south, again, look in the east, look southeast, and then it'll rise. It'll go toward midnight. It'll be basically due south at midnight, and then it will set in the west. So that's one thing to do, at least early in the evening. You may not know when Aurora is going to begin, but you'll know where to look. Okay? All right. Well, I've been on here for quite some time, guys. I'm hoping you've got enough questions answered that it put to bed any fears that you had. I see one more question here. Can an intense storm on the sun affect overall rotation speed of the star itself? No. My goodness, no. The amount of mass that's coming off of the sun, I mean, if we're talking about intense storms like what we see here at Earth, meaning even the most Carrington class events, the sun doesn't even notice that stuff. That's basically stuff blowing off its atmosphere. It's like Earth losing a little bit of air. It doesn't even notice. So I wouldn't worry about that. That's not a big thing. Any book recommendations for learning space weather forecasting? Stephen, it depends upon where your start point is. What level of expertise are you starting with? If you start with level of physics, then yeah, I've got several. If you're starting just from basically first principles, that's a lot harder. I would go with things like literally like my YouTube courses, because they start from the ground up, and I really don't see any books that I trust that start from the ground up like that. Okay. You're very welcome, Jerry and Kurt. Thank you. And again, proton storm strength does not have any correlation with the resulting geomagnetic storm strength. It's basically based on the strength of the solar flare and the shock that's being driven. These are completely fundamentally separate phenomena. Radiation storms, or proton storms as you want to call them, those are single phenomena. Coronal mass ejections, these solar storms, are different phenomena. And solar flares and radio bursts, different phenomena. All three of them happen oftentimes together, but do not conflate the three. They are not related. Okay? There are certain physical processes that are going on that happen at the same time that allow these things to go together, but do not say we have an X-class CME. X-class are for flares. X, M, C, B, okay, those are all flare classes. It's not a coronal mass ejection. CMEs, these coronal mass ejections, also called solar storms, they have G scale, right? So G1, G2, G3, G4, or as in May, G5. Okay, doesn't have anything to do with the flare size. Okay, it's a geomagnetic storm. It's how the Earth responds to getting hit by one of these, all the material, the big solar belch that the sun gave us. And then finally, when we talk about radiation storms, again, they can be driven by solar flares and by coronal mass ejections, but they are their own entity. And that's why we have an S scale, S1, S2, S3, which is what we are in right now. Okay, and we've seen S4s, but not for many years. But do not think that one connects to the other. You can have strong flares and therefore strong CMEs and therefore strong radiation storms, sure. But don't start trying to connect the dots on a really tiny, thin scale here, because, or fine scale rather, because it won't work. Okay. All right, guys. Hopefully this worked for you. I got to let my moderators hit the hay. It's East Coast time for them, so it's very late over there. Hopefully you guys are doing well. If you're in the hurricane-affected areas, stay safe. Get on amateur radio if you get in trouble. There'll be people waiting for you. Okay, and God bless.